So maybe you thought yesterday's fractions were very complicated. Well, I've got some good news for you. Now we're doing even more complicated fractions. Woohoo! Math is so fun. Okay, so we are going to basically have denominators within denominators. For instance, 1/2 plus 1/3 over 1 minus 1/6. Okay, so there's kind of two steps, right? So first we want to think of the things that are bad, the things that we don't like, okay? That's kind of like how I like to think of math a lot is what do I want to get rid of to make my life easier, right? I don't like that 2. I don't like that 3, I don't like that 6, right? Because they're fractions within fractions and they're just so messy and terrible to look at. So I'm going to try to get rid of all of them. And in order to get rid of all of them, this is what I'll call step 2, we are going to multiply by the least common multiple. So I'm going to multiply top and bottom by the least common multiple of these numbers. So I have 2 and 3, right? 2 times 3 is 6, and then on the bottom I have 6. So if I just multiply by 6, it will actually get rid of all of these complicated fractions all at once. Okay, so if I multiply top by 6, bottom by 6, what's going to happen is the 6 is going to distribute, right? So I have 6 times 1/2, which is 3, 6 times 1/3, which is 2, and then 6 times 1, which is 6, and then 6 times 1/6, which is 1. I end up with 5 over 5, which is 1. Okay, so think of the things that are bad, then try to get rid of them by multiplying by the least common multiple of all those bad things. Okay, now, of course, it's not always just going to be nice numbers, right? We might get some variables, so let's go ahead and practice that. So if I have 1 over, or a to the negative 2, b to the negative 2, right, I'm going to flip them to the bottom in my first step. So now I have a bunch of messy fractions that I don't like, okay? So I'm going to circle all those messy fractions that I don't like. Okay, and what I'm going to do is I'm going to get rid of them all at the same time by multiplying by the least common multiple, right, which is a squared b squared, right? That's the least common multiple between all those messy denominators. Now, a squared b squared times a squared, or 1 over a squared, the a squareds cancel, so I get b squared. Same thing happens in the next one, right, except the b squareds cancel, and I'm left with a squared. On the bottom, just 1a and 1b cancel, okay? So you can pause the video, do that very slowly, and actually distribute it. Now I'm going to factor the top, which is the difference of squares, and the bottom by taking out an AB. And then I realize that B plus A is going to cancel on the top and the bottom. So I'm left with B minus A over AB. Okay, please do this slowly. Show the distribution if you want. I'm not showing it each time just for sake of time. Okay, so let's do another one where we have, again, x and y on the bottom. So the least common multiple between all of these bad denominators is xy. Okay, if I distribute that xy, it's xy times 1 over x. So the x's cancel, I'm left with y. In the second one, the y's cancel, I'm left with x. And then on the bottom one, the same thing happens. But then, you know, if I take xy times y over x, the x's cancel, I'm left with y squared. Same thing happens in the next one, xy times x over y, the y's cancel, I'm left with x squared. Okay. Then I'm going to factor the bottom because it's a difference of squares. Again, hopefully you're starting to recognize them whenever you see them. And then the y minus x's are going to cancel. So I'm left with 1 over y plus x. When you watch this video, pause it in between so that you can, you know, show the distribution yourself, try to work out the problem yourself, and that's the best way that you can learn. Okay, so now even more complex denominators here, u minus v, u plus v, right? And I'm actually going to see the same denominators again, right, with different numerators. Okay, so the least common multiple between u minus v, u plus v, u minus v, u plus v, right, is just u minus v times u plus v. Now, if I take u minus v times u plus v and I distribute it across the top, across the bottom, notice that in the first term on the top, u minus v's are going to cancel. I'm going to be left with u plus v squared. And then in the second term, a similar thing happens. U plus v cancels, and I'm left with u minus v squared. And then on the bottom, same sort of thing, right? The first one, the u minus v's are going to cancel. I'm going to be left with u plus v squared. And then the second one, the u plus v's will cancel. I'll be left with u minus v squared, because there's 2 of them, right, multiplied together. And the only thing that's different between top and bottom is that there's a plus sign in between those on the bottom, right? So I can't just cancel them to be 1 because there is a difference there, plus and minus. Okay, if I expand these, I get u squared plus 2uv plus v squared, and then minus, in parentheses, u squared minus 2uv, because there's a minus sign in that one, plus v squared. And then the bottom is exactly the same except they're added. Okay, notice that I have 2uv on the bottom and negative 2uv, so those are going to cancel. Okay, then I'm going to distribute this negative across, so negative u squared, positive 2uv, and then negative v squared. The u squares are going to cancel on the top. The v squares are going to cancel on the top. I'm left with combining like terms, 4uv over 2u squared plus 2v squared. The 2's all cancel only because I have 2 in every single term on the bottom and on the top. Okay, and I'm left with 2uv over u squared plus v squared. I hope that you enjoy your homework, or at least that it's not too painstaking, and that you have a great day.